Okay, so topic 111, this is going to be part one. Okay, because I said I was going to split this into two parts because it's fairly long and it does have a couple of different things. Okay, so this is stuff that we have already practiced as far as long division, synthetic division, things like that. And it's also stuff that we've done with vertical asymptotes, domain range. It's all stuff that we've already learned. Now we're just kind of all putting it together. Okay, so let's go ahead and get started. We already know the definition of a polynomial. They keep telling us every time, or sorry, the definition of a rational is two polynomials that have been divided, right? And that your denominator cannot equal 0, right? And that whatever your denominator factors out to and solves out to is going to be either asymptotes or wholes if they have pieces that, match. Okay, so let's go ahead and go through several of these. All right, so the factored form of h of x, which I've been telling you before about finding wholes and vertical asymptotes. The first thing you should always do is factor the top and the bottom so you can see if you have any matching pieces that do this. Okay, so the top is a difference of squares, and that factors to x plus 2, x minus 2. All right, and then the bottom, product and sum, what multiplies to give you 10 and adds to give you 7, is going to be 2 and 5. Okay, so we have a matching piece, right, that does not leave any remainders, top or bottom. So we know for a fact that there is a hole at, or when, rather, I should actually state it when, because that is the formal definition that we give it, that there is a hole when x is -2. Remember to change your signs. Okay, the one vertical asymptote that is left is going to be x is equal to -5. Please, please, please make sure you're remembering to write those as equations. It makes a difference. All right, so now let's find the domain. So if I have a vertical asymptote at -5, that's not allowed to be part of the domain because you're not allowed to have that as an x. So when we write the domain, normally, normal function would be all real numbers, or negative to positive infinity, right? But we have to leave out -5. Okay, so we have to write it as a union from -infinity to -5, and then from -5 to positive infinity. Now, if you're wondering how that leaves out -5, remember, these aren't brackets, these are parentheses. So this literally means that your x values start all the way on the left at -infinity, get up to -5, but don't touch it, which is why it's parentheses and not bracket, skip over -5 and go back to the other side of it, again, starting it above -5, but not actually touching it, parentheses, not brackets, and goes all the way to the right to positive infinity. Okay, so that's how we're going to write the domain. So we need to make sure we're catching that. And when we have vertical asymptotes, if we have more than one, then we're going to have to write 3 sections. It does work that way. Okay, so same thing, and we're going to add a few more to this piece. So factored form, again, these are both, or sorry, the top one is product and sum. What multiplies to give you -12 and adds to give you -1 should be -4 and +3, right? The bottom, since this is going to be bottom heavy, they all have an x in common, right? So you can take an x out, right? If you take an x out, you're going to have x times x squared plus x minus 20, which can then factor using product and sum. So x times, well, what multiplies to give you -20 and adds to give you +1 would be +5 and -4. So I've got a matching piece. I factored it all. I now know that I have a hole. So I'm going to go ahead and fill in the hole when x equals 4, or technically, since we say x equals 4 is an asymptote, as I told you, when x is 4, there is a hole. Cross those out. All right, vertical asymptotes, we solve the bottom. Y'all need to remember that if you've taken out an x, that counts as a 0. Remember, when we factor, we then solve to get our other pieces. Solving means you set each piece equal to 0, which is why those signs change, right? So your vertical asymptotes are 0, because that's already there, and -5. Okay, 0 as the function is when we factor and solve the numerator, right? We talked about that. Just like asymptotes are factor and solve the denominator. All right, so there's only one piece left in the numerator since we have a hole at 4 now. So our 0, we set it equal to 0 and solve it, is -3, 0, or you could say x is equal to -3 since you are being asked for zeros. It's like solutions type. Okay, horizontal asymptotes, and again, this comes down to after you have simplified all your factors. Horizontal asymptotes are based on leading coefficient, okay? So if we look at the now factored form after it's been canceled, we have x plus 3 over x times x plus 5. All right, we know that's x squared, and I don't have an x squared on top. So remember, we fill in that missing piece, right, as a placeholder. I have 0x squared on the top and then basically 1x squared on the bottom. So my horizontal asymptote is going to be 0. All right, it's bottom heavy. It should be y equals 0. All right, and then the domain is just taken straight from the vertical asymptotes. What are you not allowed to have? You're not allowed to have 0, and you're not allowed to have -5. Okay, so that means we go from -infinity to -5. And then we go from -5 to 0. We're just going from least to greatest. And then we go from 0 to infinity. When we graph this, you will actually see 3 separate pieces, and you'll be able to see where they actually show up. Okay, so you are going to use a graphing calculator. I'm going to use the one that we have in class because I have the emulator on my computer. You can also use Desmos. It works very, very nicely. I'm going to go ahead and show you what it looks like. I've gone ahead and typed it in and graphed it. Okay, and as you can see, 3 very distinct pieces separated by vertical asymptotes, right? You have a vertical asymptote at 1, 2, 3, 4, 5, right here, that -5, and a vertical asymptote at 0. So if you were going across for the domain to list them, -infinity all the way to the left until you get to -5, and then picks back up again from -5 to 0, and then picks back up again from 0 to infinity. Okay, so again, Desmos or the graphing calculators that we have in class work well. Again, I'm still waiting to hear back if the Desmos is going to be imported into the AP test now that it is online. Okay, so I'm not going to draw it here. You can as far as your notes, but I know what the graph looks like, and I'm not going to put all the pieces in. I mean, well, you know what? Never mind, I will. I'll go ahead and draw the asymptotes. 3, 4, 5, -5. And then 0, and then we have a horizontal asymptote at 0, but remember that's just a, where do the ends go, right? Where do the ends of the graph go? Let's see, intercepts, my zeros of my function I only have 1 at -3, so that actually tells me 2, 3, that the graph is going to be going down between these two asymptotes, right? That's why it looks like this, because it does actually curve around and go down. Okay, so again, basic sketch based on that information. We have one piece out here. We have the one piece here. And then we have the one piece here. Okay, if you were asked to do this without a graphing calculator, you would just be substituting in some numbers to see, like think about when we were doing the inequalities, you'd substitute some numbers in that were less than -5 to see if it's positive or negative, right? So you would know it's down here. Numbers that were above 0, right, to see if it was, again, positive or negative, and it would be here. And then this has to basically go the other way on the asymptotes, right? So if this is going down, then this side has to go up. If this side is going up, then this side over here has to go down. Okay, so again, you can substitute some numbers in. These are not actually hard to graph by hand. You just have to remember the rules that we have for where the pieces are. Okay, so I'm going to keep doing some more, and we're actually going to be writing some functions today. Okay, so I want an equation in factored form. They're never going to make you write it in standard form. You'd have to multiply everything out, and there's just no point. We know what's going on in factored form. So first thing, there's a hole at 1, 2, 3, 4. Okay, so there's a hole at x equals 4, then I know for a fact that I have to have an x minus 4 on the bottom and an x minus 4 on the top, period. That's a hole. Okay, I have a vertical asymptote at x equals 2, which means the bottom, that's where my vertical asymptotes are, right, has to be x minus 2. Okay, I have a horizontal asymptote at -1. Now, the only way that I can have a horizontal asymptote at x equals -1 is if I have something that is balanced, right? So that means somewhere in there, I have to have another factor on the top. Doesn't really matter what it is. Just pick your favorite number and make sure it's not x minus 2. Okay, so whatever factor you want, that's fine. Basic sketch. And then make sure that the top has a 2. Or sorry, not a 2, a negative 1. So negative 1, and there you go. You can also multiply the negative 1 out on that x plus 5 if you wanted to, and we would consider that simplified form. And that would be negative x minus 5, right, over x minus 4, x minus 2. There you go. And that's a basic form. And again, I could have picked any other number there except, obviously x minus 2 because that would have canceled. But I have to have another factor up there, right? It has to be balanced, right? Same exponents in order to get a horizontal asymptote that's not 0, right? Y equals 0 as a horizontal asymptote only occurs when it's bottom heavy. So you got to be real careful, make sure you're paying attention to the pieces. All right, so we'll try a slightly harder one. Okay, and again, there is a hole at x is 2. So again, top and bottom, I have to have an x minus 2. Okay. Oop, not trying to do that. X minus 2. Okay, here's the thing. Your horizontal asymptote is 0, right? So that means that this is a bottom-heavy function. Okay, so y equals 0 is my horizontal asymptote. That means it has to be bottom-heavy, period. So I have to have more factors on the bottom. All right, my vertical asymptote is, that's a hole, and my vertical asymptote is 3, right? So that means I have to have a x minus 3 on the bottom. Done. That's all I have to prove as far as factored form. Okay, so again, not too bad. We're just writing some basic equations. All right. Oh, wait, nope, for this one, this does require just a tad bit more. Here's why. Because this actually has an x-intercept, and I know x-intercepts go on the top. Sorry about that. That's 1, 0, so I have to have an x minus 1 on the top, which means I need to add any other factor I want on the bottom, right? And it could be whatever you want, or it could be just a plain x. It doesn't matter. So I could just put, as long as it doesn't cancel out the x minus 1, how about x plus 2? Just whatever it is. So I have to have a higher thing on the bottom. Okay, so that's it. Again, just basic pieces. All right, so let's try the next. Okay, so there's another one. Now we're going to get into those slant asymptotes. This is why we practiced division, right? Long division and synthetic division beforehand so that we could actually get to this. All right, and we are going to be using long division. Sorry, this is just what we're going to work with because we know the synthetic only works if you're dealing with binomials, right? A linear binomial on the bottom. Okay, so they've went ahead and factored it for you. We know we have a cancel. Okay, so what do we have left? If I multiply that back out, just not in factored form, it makes it easier to divide. That would be x squared plus 2x, and then I have no constant, and it's being divided by x plus 1. Okay, yeah, I could use synthetic division on this because this is most definitely a linear binomial. So if you want to try that one, go ahead. I'm going to go ahead and use the long division just to prove to you that it does actually work. Okay, so let's see. X plus 1 into x squared plus 2x. And remember that we have those placeholders for things that are missing, so I have to have a plus 0. Okay, so x into x squared, or x squared divided by x is x. Remember, then we go back and multiply by both pieces. And then we subtract to make sure we're not screwing up and adding our second pieces. We're not supposed to. 2 minus 1 for the x's, that's just x plus 0. X into x is plus 1. So my slant asymptote, as you can see, has a slope of 1 and has a y-intercept of, or rather, it has a slope of 1 and a y-intercept of 1. Okay. So for problems like what we have on the bottom of this page, right? You're going to have to use the long division because that is not a very easy linear binomial. You're not going to get the right answers if you try to use synthetic. So we're going to go ahead and do long division. 2x plus 1, 6x squared plus 7x plus 6. Yay, no missing pieces. We don't have to put anything in. That's good. All right, so remember, first term by first term, 6x squared divided by 2x is going to give me 3x. Okay, multiply it back out. First term's always going to cancel back out. Plus 3x, we are subtracting. 7x minus 3x is 4x. Carry down the next number, plus 6. All right, we're doing the same thing again. First term divided by first term. Our new first term is 4x. 4x divided by 2x is 2. 3x plus 2, multiply back out. That would be 4x plus 2. When we're doing this specifically for slant asymptotes, please keep in mind that the remainder doesn't matter. So the equation of my asymptote is 3x plus 2. All right, so let me show you why this does not work. It's harder when you're doing synthetic. I'm going to do it over here. If I were to solve this, 2x plus 1 equals 0, I would get x is equal to negative a half, right? And that's what we would use as a multiplier for the negative 1/2. And I write down my coefficients, 6, 7, 6. Carry down the first number, 6. Automatically, I know right now it's not the right slope. Multiply by negative a half, I get negative 3. Add them together, I get 4. Do you see the relationship there? Because that would be y equals 6x plus 4, and technically that's 3x plus 2. You would have to then divide by that 2 that was there. So again, unless you remember the shortcut, you know, when you're dealing with linear binomials like this, it's better just to go ahead and use the long division to prove what your slant is. Okay, so your quotient is 3x plus 2. That's the equation, and the remainder is 4 over 2x plus 1. Okay, so but the first part of it, right, where you're starting with the linear, is always going to be your answer for your slant asymptote. And again, yes, this does work. I could do this with 3x minus 1 or 3x plus 1, and then whatever I would get, I would then have to divide by 3, and it would actually give me the correct problem. Okay, so, but that again, that's a shortcut, and I would rather you do it the long way and do long division first and guarantee you're going to hopefully come up with the right answer rather than forgetting to divide this back out and getting the wrong asymptote. Okay, almost done with this section. So let's try a couple more. We're going to actually go through and get all these pieces now. All right, so 2x plus 1 into 6x squared plus x minus 5. Okay, so 6x squared, first term divided by first term 2x gives me 3x. Okay, multiply it out. Make sure you distribute and that you are actually subtracting both sets. X minus 3x is negative 2x. Carry down the negative 5. And now my new first term is negative 2x divided by 2x. That's negative 1. I can stop. This is all I need if I want the slant asymptote. It is y equals 3x minus 1. If you keep going, you're going to get negative 2x minus 1. And if you subtract, negative minus negative would be gone. Negative 5 minus negative 1 would be negative 4. So if you actually needed the remainder, like we talked about when we were doing long division, it would be negative 4 over 2x plus 1. This is if they want the entire quotient, right? But if all you want is your slant asymptote, you can stop once you get to your y-intercept, right? Because the first term is going to give you your slope, and the second term is going to give you your y-intercept, and you can actually stop there. All right, so we're going to keep going. We are going to, oh boy, that's a big factor. We know we got to take an x out of the top. That's going to give me x squared plus 4x minus 12. And then over x squared plus 7x plus 6. These are both product and sum. Again, what multiplies to give you negative 12 and adds to give you 4. That's going to be plus 6 and minus 2. Right? And then the bottom, what multiplies to give you 6 and adds to give you 7 is going to be 6 and 1. Okay, so this is good news. We have a whole, which means my thing is not going to be nearly so nasty to try to divide. Okay, so the actual factored form, after it's been simplified, really is x over x minus 2 divided by x plus 1. So we are, once again, it's top heavy, so we know it has a slant asymptote. Multiply it back out and do your, actually, let me get some room. Multiply it back out so you can do your long division. All right, so x times x minus 2 is x squared minus 2x plus the 0, right? The placeholder, we don't technically need it once we finish dividing. Okay, so divided by x plus 1. X squared over x is just 1x. Multiply back out. Subtract. Cancel. So negative 2x minus 1x is negative 3x. Pull down the 0. And now I'm doing negative 3x divided by x, which is negative 3. So I have my slant asymptote already. It is y equals x minus 3. There are no horizontal asymptotes if you have a slant asymptote, period. Okay, vertical asymptote again. Factor and solve the bottom. My vertical asymptote is negative 1. Okay, so that's everything for that one. We could have included our x-intercepts at 2 and 0. We could have included our y-intercept, which would have been 0, because 0 over 1, as far as constant terms, would be that. And we could actually graph this with a fairly good picture, just with all that information. Okay, so I think this is the next to last one. All right, so let's see what we got. So first off, this is 2x times x times x. So your leading coefficient would be 2, or leading term rather would be 2x cubed over x squared. So right away, it's top heavy. So I already know I have a slant asymptote, right? And if these don't say slant asymptote on them, those answers are gone. I already know they have it. If I factor the bottom, what multiplies to give you 1 and adds to give you negative 2, let's see. Oh, that would be x minus 1 times x minus 1. Okay, so that means I have a hole at 1. Okay, so let's see. This one says slant asymptote and 1 hole. I'm done. Oh, wait, no. I have a double. So I actually don't have a hole anymore, right? Because x minus 1 now becomes the vertical asymptote, because that you can't have a hole and a vertical asymptote at the same place. Vertical asymptote, whatever the slant will be, I have no clue. So actually, it's D, because factoring to check, remember that I said it's bottom heavy on the factors. That means since it's left over, it becomes an asymptote and not a hole. So it's process of elimination. Okay, this one's going to be a little bit harder, so bear with me. It's going to take a little bit of time, but this is the last example. Okay, and it's using limits. So the limit as x approaches positive infinity, so that's going this way, is negative infinity, which means the graph has to be going down on this side. The limit as x approaches negative infinity is positive infinity. That means this side has to be going up, period. Okay? The limit as x approaches 1, so if that's 1, and that's what they're giving me as a limit, I know that's an asymptote. Oh, sorry, negative 1. So I have an asymptote at negative 1. As I come at it from the left side, it's going down. If I come at it from the right side, it's going down. So basically, this is going to be something that is got a slant asymptote in it, but a basic equation or a basic graph would look like that. And then we want it to have kind of the same curve here, so it would be like that. Just so it looks like it actually has a vertical asymptote right here that causes it to do this. Okay, and that's a basic graph based on limits. Again, knowing which way it goes and knowing, left and right and which way. Again, if they tell you to draw a graph with this and they give you this as where you're headed for on your x, that's guaranteed to be a vertical asymptote. MPTOTE, there we go. Okay, that is it for section 11, part 1.